in this video we're going to look at the second part here of lesson 4.2, which is on law of sines. Now, the cases for laws of sine that we've talked about so far have been that we can use it to help us solve a triangle for angle, angle, side, or angle, side, angle. And the one that we haven't really solved for yet is side, side, angle, which is called the ambiguous case. And so that's what this video is really going to address here, is this ambiguous case. So where ambiguous means that it's not a finite number here of triangles that we can get. So from side, side, angle, there's a possibility that there's no triangle at all that can exist. There's a possibility of one triangle, and then there's the possibility of two triangles that we can get from this. So if we have the side, side, angle case, before we start solving the triangle that may be there, or in fact the two triangles that may be there, we have to establish how many triangles we have first. So let's look, and let me give you the cases here that we can do for this to help you decide how many triangles that you have. So the first one we'll look at here is the obtuse case. So let's look at the angle given as an obtuse angle. And so, you know, you have two sides at an angle, and what we're saying here is the angle given would be the obtuse one. So we look at two triangles we get, and this one's really easy to determine how many triangles you're going to have in this case. Now, in the obtuse angle case with side, 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 you're either going to get one triangle or no triangle. Okay? So let's say in both cases that the angle given is 100 degrees. So that would definitely be the obtuse case. Now, in both triangles, I'm going to give you two sides here. So let's say this side is 7 and this side is 4. And then on my other triangle, I'm going to switch those. Now, let's look at how that this is side, side, angle. Because notice I do have two sides and an angle in both triangles. Now, because the angle is not in between right there, it's not side, angle, side. So if the 100 would have been in between those two sides, like right there where I'm marking it there, then that would be side, angle, side, and that would be a case for law of cosines instead of law of sines. So that's definitely their side, side, angle, because side, side, angle is two sides and the non-included angle. So again, that means that the angle is not in between the two given sides. Now, what we're going to use in this case for the obtuse case is this fact right here. The largest side, or I guess we could say the longest side, should be opposite the largest angle. Now, in an obtuse triangle, the obtuse angle would have to be the largest angle. You can't have a triangle with two obtuse angles because it would go over 180 degrees. So let's look at both triangles, and let's notice on the first triangle here I have a side 7 and I have a side 4. So 7 is clearly the longest side. And so the longest side there is across from the biggest angle. So that logically makes sense. So since the 7 here is the opposite side and it's the largest side, it's across from the largest angle, therefore this would be a triangle. And so you would get one triangle out of that. Okay, then just a minute later we're going to solve a triangle, and we'll solve it out by using law of sines. Right now we're just trying to establish how many triangles. Now, in this one, all right, take note here that across from 100 degrees is only 4. And so to be a triangle, the longest side has to be across from the largest angle, and that's not the case. So really that triangle would not exist. What would really happen here is that this side of 4, it wouldn't be long enough to touch the end of the other side there to make a triangle. So it really wouldn't exist there. So in this case, we would have no triangle because the longest side is not opposite of the largest angle. So the obtuse angle case is one of the easier because it uses this logical statement. So it has to sort of obey that theorem of geometry to have a triangle exist. Now, the acute angle case is actually a lot more complicated. So let's look at the acute angle case. Okay, so this is an side-side angle where the angle that would be given would be an acute angle. Okay, so let's look at a couple of triangles here. And this time I'm not going to have any specific values here. Okay, especially for the angle. Let's just say that the angle is alpha there. So let's have two different cases where we have an alpha angle and how the sides opposite compare to that. Right, so I'm going to use the two numbers that I used last time. I'm going to use 7 and 4 there. Okay? And on my other triangle, I'm going to switch those. Now the first triangle is the easier case. Okay? So watch or notice this statement here. If the side opposite is bigger, and that's what we have here. So from alpha, the side opposite is 7, and 7 is bigger than 4. So if the side opposite is bigger, it's just like it was in the obtuse case. You just have one triangle. Okay, and that one's pretty straightforward. Now, the one that is not straightforward here is the second triangle. So notice, on the second triangle, the opposite side is not bigger. So what we have to do is we have to make a comparison. Okay, so we make a little statement here. If the side opposite is smaller, then what we have to do is we have to make a comparison. So let me show you what to compare. So what we're going to do is we're going to compare that opposite side, which would be 4, compared to the other side times the sine of the angle. It would be 7 times the sine of alpha. And so in this empty box, what I'm putting there is that could be less than, greater than, or equal to. Okay? So if we get 4 is less than 7 times the sine of the angle, again, if this is less than, then that means there is no triangle. You can have a triangle to exist. If this is equal to, which is pretty rare, you would have one triangle, and the significance here, if it is equal to, is it would be a right triangle. Now, in the case that it is greater than, that means you would have two triangles. You could have two triangles that exist with that. Now, I'm going to try to illustrate to you how we can get two triangles from just, one set of information here. So, I want you to imagine here, I could have is a triangle, and I want you to think about this third side as to what could happen, how I could draw the third side. So, one thing that happened was the third side could go down here, and basically what would happen is that angle there would be obtuse. Now, where I can make two triangles is I can figure out how to do it here. And have to rotate this. It's the wrong direction. let me just do it this way. What could happen, instead of this leg here coming out to the end, is it could go and make an acute angle and come in this way. And so therefore that would give me two triangles. Now, what could really happen actually here too is the leg could come straight down, which would make a right angle, which will give me only the one triangle there. So that's how visually that works. Now you don't really have to understand that to be able to solve these problems. And again, visually that's how that works. Is that this red side could go two ways. It could go out to make an obtuse angle, or it could go inward back toward the other point to make an acute triangle there. So it just depends on how you kind of look at it there, is you could have two triangles from that third side, either going out to the right or going down to the left. And of course it would make one triangle just by going straight down. Now, let's look at some examples here where we don't solve them, but all we're going to do is just determine how many triangles I would have. Okay, so let's start off with this example here. Let's say we have a triangle where the angle is 100 degrees, and this side is 10 and this side is 7. So let's see if we can figure out how many possible triangles would that give you. So notice, first off, it is the side-side angle case. Now notice about the angle and sort of ask yourself, is this obtuse or is it acute? So the answer is this would be an obtuse angle there. And so if it's the obtuse triangle, remember it just has to logically make sense that the longest side has to be across from the biggest angle. And so does that make sense here? Is the longest side across from the largest angle? Yes, it is. So this would just be one triangle. Okay, let's look at another example. Let's say the angle given is 104 degrees, and this side is 8 and this side is 11. So again, it's the obtuse angle case. So we're going to ask here, is the longest side opposite the longest or the largest angle? And it is. So this would be, again, one triangle. Okay, let's do another example. Let's say this angle is 94 degrees. The opposite side is 8, and then the adjacent side is 10. So 94 degrees is definitely an obtuse angle. So it's the obtuse angle case. Now, is the longest side opposite the largest angle? No, it is not. Okay, really, to be a triangle, these two numbers should be switched. So this would be no triangle. And we like the no triangle ones because when we have no triangle, we don't have anything to solve for because the triangle wouldn't actually exist. Okay, let's look at some more here. Let's just do some acute angles now. So let's say that this is a 64 degree angle, and this side is 7, and this side is 10. Okay, now the acute angles are much harder to think about. So let's kind of go back just a minute and look at our case here about the acute angles. Okay, so on the acute angle, let's start with the first case. If the side opposite is bigger, then it's one triangle. Well, let's see if what was the case here was. Okay, so is my opposite side bigger over here? No, it's not. So it's very unlikely that it's going to be one triangle. I'm going to have to do that comparison and look back at what exactly that we are supposed to compare. So if the side opposite here is smaller, then we're going to compare that side that's opposite compared to the other side times the side of the angle. And so if it's less than, it's no triangle. If it's equal, it's 1. If it's greater than, it's 2. Let's go back, and that's what we're going to have to do in this problem. So we're going to have to compare here the opposite side, which would be 7, compared to the other side, 10, times the sine of, and it's never the cosine here because we're doing all the sine, of 64 degrees, which is the angle. And so now what I'm going to have to do is get a calculator in degree mode, and let's calculate it here. All right, what's 10 times the sine of 64 degrees? Okay, so I got my calculator here, but this is about 9.0. Okay, at 8.987, pretty close to 9. And so in this case, 7 would be less than 9.0. So less than means that this is actually not a triangle. So I wouldn't have a triangle that existed there. All right, let's look at some more, especially like that with the acute angle case. All right, let's try one like this. So let's say it's an acute angle given, it's 52 degrees. Let's say this side is 14 and this side is 13. So let's notice, we're going to have to do a comparison because it's an acute angle, or can we just say it's one triangle? So notice that the side opposite is the smaller of the two. Therefore, I'm going to have to make this comparison. Now, think about this. If, write this. If these are switched, okay, then the larger side would be opposite of the given angle. And so in that case, that would just be one triangle because the bigger side is opposite of the angle. But with the smaller side on the opposite, we have to make that comparison. So that comparison is we take the side that's opposite and we compare it to the other side times the sine of the angle. So this would be 14 times the sine of 52 degrees. Okay, so let's see, what is 14 times the sine of 52 here? Okay, so I got like 11 point something here. I got about 11.0 for that. And so in this case, 13 would be greater than that. So if it's greater than, that means we could have two triangles that could exist here. And again, the way that this would work is we can take this 13 side. Let me try to draw it this way at different settings here. And let me try to explain this again on how this would work. Okay, so there again, what can happen to make this two triangles is I can take this side, and it still won't work like that. Never mind. I have to pull up a video on YouTube and actually show you guys what happens there. Now, that's going to be two triangles there because we've got that the opposite side would be greater than the other side times the sine of the angle. Okay, let's look at another one. Let's try. Let's see what happens on this one. 61 degrees. That side 7, and that side 6. Okay, so notice, again, the opposite side is the smaller of the two, and it's an acute angle. So I've got to compare 7 compared to 10 times the sine of 61 degrees. Okay, so let's calculate here again. What's 10 times the sine of 61? So that's about 8.7 there. So 7 would be less than that there. So less than means I'm not going to have a triangle. So no triangle for that. Okay, let's do about 4 more examples of this, and then we're going to actually start solving triangles here. Okay, so we'll look at all these at the same time here. So let's look at each one of these and let's determine how many triangles I could have in each side-side angle case. Because each of them are side-side angle. And by the way, when I'm going to draw my pictures, when I'm solving my triangles, this is the way I always draw it. Always draw that angle in the bottom left corner. So that kind of helps me orient to the same picture every time I'm looking at side-side angle. Now, on the first one here, we've got the 41 degrees. And so notice the side that's opposite is the bigger one. So in the acute case, think, well, what happens when the side opposite is the bigger one? Well, that just means one triangle. So I do not have to make a comparison when that's bigger. Now, on my next triangle, still have 41 degrees, but now the sides are switched. So the smaller side is opposite. So to tell how many triangles, I'm going to have to do that comparison. So I'm going to compare 14 compared to 20 times the sine of 41 degrees. Okay, so let me my calculator here and let's figure what's 20 times the sine of 41 degrees. And so that's about 13.1. And so 14 would be greater than that, so that would be 2 triangles. Okay, notice the next two examples are different because they're obtuse triangles. So with obtuse triangles, you just have to make the logical sense here that the biggest side should be across from the biggest angle. So notice on the bottom left one here, 12 is the biggest side, yet it's not opposite of the biggest angle, because if this is an acute triangle, the 91 degrees would be the biggest angle. So this one is no triangle here. Now, if I look at my next acute one here, the biggest side again is 12, and it is opposite of the largest angle, so this would form for me one triangle. Now, let's actually go through now with the law of sines, and let's solve some of these, especially one here where you would have 2 triangles, because those are kind of complicated and really involved problems. All right, so let's look how they're going to present them. So the side-side angle is going to be a giveaway, because what they're going to do first is they're going to ask you how many triangles would be formed, and then to solve any of that result. It says 2 sides in an angle are given below. Determine whether the given information results in 1 triangle, 2 triangles, or no triangle at all, and then solve any triangles that result. Now, I'm going to draw, usually they'll have a picture for you, but I kind of like to draw my own picture on these problems. And so the reason why I like to draw my own picture is I like that angle to be in the bottom left hand of my triangle. Now, notice that you do have 2 sides in an angle. And let's see if you can kind of pick up something about the angle. What's maybe a little bit different about the angle? It's 140 degrees, therefore it would be an obtuse angle. So I'm looking at the obtuse case. So I'm going to draw an obtuse triangle. And there again, I'm going to draw my own picture. I'm not going to rely on figures. So I got beta there is my 140. And then we got sides B and C. So this is beta angle. And so little b is going to be across from that. So 7 would be there. Now either angle could be C. I'm just going to make the top one C. And so that would make, or I guess I shouldn't say C here, but what I should say is gamma. And then this angle down here would be the alpha angle. So notice little b is across from beta. And so little c would be across from gamma. So little c would be 5, would be down here. Now, it's my obtuse angle case. And so notice from 140, my obtuse angle, the largest side should be across from the largest angle. So let's see if that's true. Is the largest side across from 140? It is. So that means that this would be one triangle. And so that would be the first thing that you would enter in on your, you're typing in the computer, is you would hit 1 for one triangle, and now it's going to ask you to solve the triangle. So the way that I can solve the triangle is to use law of sines. So for side-side angle case, and for angle-side, angle, we use law of sines. So let's set up a law of sine proportions here. And so notice what I'm going to start with is the angle and the side that's across from it that would be given. So that would be beta and little b. So I'm going to do little b over sine of b, which would be 7 over the sine of 140 equals. Now let's set up another ratio here. Now my other ratio, I'm probably going to use the 5 somehow, but notice the alpha angle and what would be little a over here. I don't have either one of those, so I really can't do anything with alpha or little a. So we'll skip over that ratio, and I'm going to use the one here that goes with 5. So the one that would go with 5 over the sine here of gamma. Now, we can cross multiply here, and what we can do is we can solve for the angle gamma. So we would get 7 times the sine of gamma equals 5 times the sine of 140. Okay, so now I'm going to solve for gamma. Now I can't divide by 7 time, but I can divide by the 7. We divide off 7 on both sides here. Now I'm going to punch in my calculator. 5 times the sine of 140 divided by 7. And so I get this is about 0.45913. And then over here on the left side, I would be left with the sine of gamma. And so this is a trig equation now. We should know how to solve this, just in case you don't, I'll tell you here. So my answer is not 0.45913. That's the sine of the answer is 0.45913. So what I have to do now, my calculator, is do the inverse sine, not necessarily of this number, but say inverse sine of the answer. So when you punch in now inverse sine of the answer on your calculator, you should get here that gamma, the nearest 10, should be about 27.3 degrees. Now, what I would need to do on my scientific calculator would be to store all those decimal values, because I'm going to need it to find my other angle. So we're going to get the gamma angle is 27, or about 27.3 degrees. Now, notice since we found one of the two angles here, that we're given one and we found one, we can find angle alpha by using that they should sum up to 180. So what I can do on my calculator here, I'm going to write it out, but I'm going to put it on my calculator here too, is 140 plus 27.3, and then take whatever that is and subtract it from 180. Now I'm going to do it all on the calculator because I need all those decimal places in that 27.3 angle. So I'm going to say answer plus 140 is about 167.33, and then 180 minus answer, and that's going to give me my alpha angle here is about 12.7 degrees. And there again, I might write down 12.7 as my answer here, but I need to use accuracy. So I'm going to use 12.7 degrees on paper, but on my calculator here it's 12.66875. So when I'm going to find what's left here, that little side A, in a second, I'm going to use all the decimal places to do that. Now, let's work on finding A. So you remember previously here that I had left off the alpha and the A ratio because it didn't have enough information. Well, now since I found angle alpha, I can add to that proportion. So now I can write a third one here with my alpha one. We can say we have A over the sine of 12.7 degrees since we found that now. And there again, I'll use my first ratio in the proportion to cross multiply with. So we'll cover up that middle one and then cross multiply with the outside too. So that would give me 7 times the sine of 12.7 degrees equals A times the sine of 140. Okay, and now we can solve that. We can divide both sides here by the sine of 140. Now, when I key this in my calculator, keep in mind 12.7 is not exact, so you should still have it on your calculator. So now type in 7 and then sine of the answer divided by the sine of 140. Okay, so we should get side A here to be about 2.4. Okay, so notice, you do have to maintain accuracy by using the decimal places, and I highly suggest you, if you want to store those numbers, you can certainly do that on your calculator using that store function. Okay, let's look at another. So remember what we did first here. Go back. The side-side angle, you had to tell how many triangles that you had to go with first. Okay, now this one, same idea. We have two angles, or excuse me, two sides and one angle, and we've got to decide how many triangles first. Now notice this angle is an acute angle instead of obtuse, so we have the acute angle case. So we've got 70 degrees here. It's our alpha angle. And so little a would be opposite of that. And then B, we could just put anywhere across from our beta angle. So we'll put it at the top. So put the 10 there. And let's just fill in the other parts of my triangle. So I got alpha, beta. This one over here would be my gamma angle. Gamma is opposite of little c. I'd much rather they use A, B, and C than alpha, beta, gamma. But that's just the way they do that. Now, let's look at this, and let's determine first how many triangles. So it's the acute angle case, and the smaller side is opposite of the angle. And so that means we have to make that comparison to tell how many triangles. So we're going to compare 8 compared to 10 times the sine of 70 degrees. So let's see how this works out. 10 times the sine of 70 is about 9.3. So 8 here is less than 9.3. And that's good news here. Because that's less than, that means no triangle exists. And so if there's no triangle, I don't have to solve for it. So I kind of like the ones that come out with no triangle, because now I'm done. All right, let's look at the next one. Okay, now this one, I left a picture on it, even though I'm not going to use it here. Again, I've got an acute angle on my picture. So I'm going to put that acute angle beta in the bottom left like I always do. And little b is 5. We'll put gamma at the top here. And so across from gamma we got little c. So think of gamma as being big C. And then so my other ones here, this would be angle alpha, and this would be side little a. Now, across from 20 we have 5. So it's the acute angle case, and the smaller side is opposite, so I have to compare. And there again, if this was 7 and this was 5, it would just be one triangle because you have the largest side across from a given angle. But with the smaller side there, we have to do that comparison. So I'm going to compare 5 to 7 times the sine of 20 degrees. So let's see, 7 times the sine of 20 degrees here is about 2.3. And so 5 is definitely greater than 2.3, which means this is 2 triangles, which is not good news. Okay, so not only do we have to solve this triangle, but we have to solve 2 triangles. So it's going to take a lot more room here. So what I'm going to do is draw a second triangle. Then I'll also have to solve. Then we'll draw this one in red. So we can kind of keep it separate here. So the given information is still going to be the same, but everything else in the triangle will be different. Now when I do this triangle, I'm going to do what we call primes there. So that'll be beta prime, gamma prime, and alpha prime. And this will still be 7. That side will still be 5. And we'll call this one little a prime. Now, we're going to use laws of sine here to get us started. Now, I'm going to start with my original triangle, the blue one, and what I'm going to be able to do is find an angle. Now, let's see if you can set up. Notice what angle and what side opposite are given, the 20 degrees and the 5. So that'll be my starting ratio. So I'll have 5 over the sine of 20. Now, notice again with the alpha and side A, you're not given either one of those, so that's not helping me out right now. So let's go to the gamma one. So we have 7 over the sine of gamma. So now I can find the gamma angle. So we can cross multiply here. We can get 5 times sine of gamma equals 7 times the sine of 20. Now I'll divide both sides by 5 here. We can cancel. So we get the sine of gamma equals, now let me calculate, 7 times sine of 20 divided by 5. So that's about 0.48788, so forth. So that's not gamma, that's the sine of gamma. So to find gamma, we would do inverse sine of that value. So I'm going to punch in my calculator now, the inverse sine of answer. So you should get here for gamma, should be about 28.6 degrees. Now, there again, I'm probably going to store that value because I'm going to need it later. Okay, so our gamma angle here is about 28.6 degrees. Now, what I'm going to immediately do after I find that angle, in other words, I'm not going to do anything else until I do this next step. And that next step is to find over here gamma prime. Okay, now it's very easy to do, it's just a little memorization thing. But it is imperative that you immediately find that prime angle once you find the first angle. So once I find that first angle, I immediately find the prime angle on the other triangle. Because it's not going to be the same, it's going to be different. Now, it's very easy to find. The way that you find it is you say 180 minus the gamma angle in the first triangle. So I would just say here, 180 minus that 28.6. And now what I'm really going to push in my calculator here is 180 minus answer. And so I'm going to get my gamma angle in my other triangle to be 151.4 degrees. And now that's an estimate here, so let me show you my triangle. And there again, I'm probably going to store it in my calculator so I can use it later. Now what I've got in both triangles is I've found the 2 of the 3 angles, so now we can find the third angle. So back to my blue triangle, I'm going to add together 28.6 and 20 degrees, and then take that and subtract it from 180. Now the thing is, this is why I told us to store that value. So we're going to have to bring up the exact value, and then add that to 20, and then subtract that from 180. Oh, I cleared out everything. So let me see, I'm going to do 28.6, that stored value, plus 20, and then subtract that from 180. Okay, so we should get the alpha angle here is about 131.4 degrees there. Now, let's go to alpha prime in my red triangle. So my red triangle, I'm going to have to pull up this from the stored value. So the 151.4, okay, there again, you would need to have stored it, plus 20 is 171.39. Now I'm going to subtract that from 180. And so we should get for alpha prime should be about 8.6 degrees. Okay, now notice we found everything in both triangles except for the side A's. And note that they're going to be different here in both triangles. Now, I'm going to do my blue triangle first and find little a. So, you remember earlier, I mentioned that on the alpha angle inside A that we didn't have either of them. Well, now we do have the alpha angle. It's 131.4 degrees. So I can add to my proportion here, and I would have A over the sine of 131.4 degrees. And so now I could cross multiply with my first ratio there where I had both of them given. So I can cover up the middle one and cross multiply with this. This will give me 5 times the sine of 131.4 degrees equals A times sine of 20. And now we can solve for A by dividing both sides by sine 20. But there again, when I punch this in, I'm not going to punch in the 131.4. I'm going to bring up the stored value. And 5 times the sine of that stored value divided by the sine of 20. All right, so we should get here little a is about 11.0. Well, I got 10.96, which would round up to 11.0 here for little a. Now, for little a on my red triangle, I'm going to have to set up a different proportion because it's a different triangle. So I'm going to set up a whole different law of sines on it. I'm still going to use that first given, the 5 and the 20 degrees. So we're going to have 5 over the sine of 20 equals, now we're trying to find little a prime, so we say little a prime over the sine of alpha, which was 8.6 degrees. Okay, so now we cross multiply, we get 5 times the sine of 8.6 degrees equals a times sine of 20. So we divide both sides by sine of 20. So now finally here, get punch in now 5 times the sine. Now I can't push in 8.6. I have to get that exact value. So if you've stored everything when you do a two-triangle problem, you have to store those angles. And you may want to write on the paper, maybe in the margin of your paper, what variable did you store, which angle. 5 times the sine of that exact value there, divided by the sine of 20. Right, you should get that that's going to be about 2.2. That little a prime up here is about 2.2. Okay, so you notice that a two-triangle problem is very, very involved. You're not just solving one triangle, you're finding two triangles. It requires a lot of work here and a lot of storing in your calculator so that you can maintain accuracy. So this is the worst case here of laws of sine and cosine is the two triangle problem. Okay, so we may do one more of these in class if you need to here. You'll let me know. If we do need to look at another two triangle problem, then we can certainly do that. Let's look at maybe one more example here. Again, where we have to find the number of triangles first. Okay, so notice this one is not the acute angle. Instead here I've got an obtuse angle. So this one's going to be a little bit more straightforward here. We've got 140 degrees is our gamma angle. Now across from gamma we should have the side 7. C goes across from gamma. Now we'll put A at the top. So that would put little a there to be 5 down there. So this would be my beta angle, and I guess instead of a angle up there, I should call that alpha. Now, so let's notice it's an obtuse triangle, and the largest side is indeed across from the biggest angle. So we would have, in this case, one triangle. Now I could set up laws of sine here to solve for this one. And so let's use the one that's given here. We could say 7 over the sine of 140 equals, now notice on my beta angle and across from my beta angle, which would be little b, I don't have either one of those, so that's not helping me out. So I'm going to have to go with the alpha angle because I know the opposite side there is 5. So it'll be 5 over the sine of alpha. Now let's cross multiply and we'll solve for alpha. So 7 times sine alpha equals 5 times sine 140. And then we'll divide both sides by 7. 5 times sine of 140 divided by 7. And so that gives me the sine of alpha to be about 0.4591. And now we'll do inverse sine of that, so inverse sine of answer. And so my alpha angle is about 27.3 degrees. Let's write an alpha here, that's about 27.3 degrees. Now I'm going to take 140 and add it to that, so 140 plus answer. And so that's about 167.3, and I'll take that away from 180 because we have 180 degrees in the trunk. So this gives me the angle beta here is about 12.7 degrees. And now that I've added here, or I found the beta angle, now I can now find the side that's across from it, the little b side. So I can add to my proportion now. This would be equal to b over the sine of 12.7 degrees then. And I can cross multiply again with that first one that was given to find the little b. So I'm going to cover up the middle one and cross multiply. That will give me 7 times the sine of 12.7 degrees equals b times sine of 140 degrees. And now I can divide both sides by sine of 140. Cancel. And then we'll put in my calculator here. 7 times the sine of, now I'd either have to store that value or just kept it in there. So 7 times sine of answer divided by sine 140. So that's about 2.4 there. So what will be there is about 2.4. So that one was only one triangle. The obtuse angles are definitely the better cases. You either have one or none. Again, it's that two triangle problem. It's probably going to be the worst in this.